Hello guys, my name is Aman and today we will gonna solve a problem statement which is based on Titanic death prediction, in which we have to predict whether uh, this person will gonna die on the ship or not. Without further wasting time, let's import some libraries and let's see the data. What is the data tells about the problem? Let's try to import pandas as PD, import numpy as np, import cborn as sns, import matplotlib.pyplot as plt, percent matplotlib in inline. Okay, after importing some library, let's see the data. What is the data? Then we can look what we can do in that data. pd.read csv train.csv. Let's look what is our data. Here is our data, and by seeing the data, it has I think 12 columns and 891 rows, and the kind of data is miscellaneous, where we also get discrete values and continuous value, like fare is continuous value, and nearly all the other values are kind of discrete values. So what is the this data is telling about? First, the column is passenger ID, which is normally the ID of the passenger, and this is the important column, survived, where 0 means the person has died and 1 means the person has lived. It is already encoded, so we do not have to encode it. And I think P class is the class where the person was traveling on the ship, and here is the name of the person, here is the gender of the person, age of the person, and SIB SP. I don't know about this data. What is this data about telling? And patch. I think this is kind of class variable uh, in which the person stays, but we will try to look what is this data telling about. And generally it's the ticket number, and it is the fare of the ticket, and it's the cabin, and it's embarked. All the other columns are representing the class of the Titanic ship, I think. And let's firstly try to see is there any none values or not. Data dot is null dot sum. I think Ace has 177 null values and cabin has nearly 687 null values, and total number of values we have 891. So by seeing this, we can clearly uh, drop the cabin column because it will not gonna help us. And age column has a 177 field. What we can do is we can just replace the age column by the mean of average. So our data, we should retain our data. We If we just try to remove the 177 age field, we gonna lost very much data. Okay, so let's try. Let's drop the cabin column, so it's not very necessary for us. Data dot drop. Let's drop cabin column, and we have to give the axis. Axis is equal to 1 means we are dropping the data from column. Let's just run this. Mm, What is the problem there? Kevin not found. Okay, what we do? Okay, C is the capital here. So we have written now. It has been done. Now let's see our data. Now let's do one thing. Let's uh, replace the age column. Replace the age column with the mean of it. Okay, and embarked has also two null values. So what we will gonna do in embarked, we gonna uh, replace the two null values in embarked with the mode of its. As you know, already know what is the mode. Mode is the frequency of the data which occur in the particular field. Okay, so let's do it. Let's first replace the age column. Age dot fill na np dot mean of what what is the mean we are trying to data of age. Okay, now let's run this. Now let's check our data is dot is null dot sum. Oh, we have to save it first. Okay, data is equal to data is dot fill na. Now it's gonna change. Okay, we have replaced the age 177 null values of age with the mean of it, and now what we gonna do, we gonna replace the embarked column with mode of it. Okay, let's see what is the what is mode, what is the maximum number of value in it. Let's first encode it, and then we'll find its mode. Okay, because it's a discrete value, and we should encode it first. Okay, so what the what column we should encode? We should also encode gender column, and we should also encode impart learn dot pre-processing, import pre-processing. Yes, yes, label encoder. Okay, now it's good. Let's make the object of that. LB is equal to label encoder. Okay, now let's change our data. Data embarked is equal to LB dot fit transform method we have to use, and what column we have to pass embark column. Okay, I think one column has been encoded. Now encode the gender column also, which is sex column, is equal to LB dot fit transform data. Okay, data, or we have seen our data. Now after we have encoded everything, now which column we will gonna take? We will gonna take survived p class, gender column, and age column also, and sib sp parch, and fair, and embarked. All the column we gonna take. Let's just drop the uh, make index. Let's just make index to passenger ID. Okay, data dot reset index data dot index passenger passenger ID. I think we have not any work of passenger ID, so we can just drop that column. Data is equal to data dot drop passenger ID, and axis is equal to 1. And we can also remove the ticket ID because it's will not gonna help us. Ticket column, and we can also remove name column. Name column. Now it's, I think it's had been done. What's the problem there? Passenger ID not found. Okay, T is capital. Make it small. What's now problem? Passenger. Oh man, let's copy that. Now it's gonna happen. Okay, let's see our data. I think we have performed our data. Now let's make our X column. X is equal to our survived column. No. X is our data dot drop survived column, in which axis is equal to 1. Okay, and our Y column is survived column of data survived. Okay, let's see our data. Here is our X. Let's put 2 column because the shape will be 0. Let's see our Y column. Now it's good. 891 891. Okay, let's try to split that column, and after splitting the column we will try to implement some machine learning algorithms on it, and we will try to see how much accuracy we are getting at least. Okay, let's import from sklearn dot model selection, import train test split. Okay, what is this open, man? Just close this. Train test split. Okay. Mm, let's divide our data into xtrain comma xtest comma ytrain comma ytest. Let's call the column, and after that we'll pass our data, and we will divide it. 25% of the data will be test data, and 75% of data will be our training data. Let's give it the test size, or test size is equal to 0.25, and let's give a random state so it can shuffle on. Random state is equal to 2529. Okay, after that let's do partition, and I think it's a majorly the discrete value. So we will try to implement firstly the random forest classifier model, because we have to classify either the people or the person has died or not. So let's first apply the random forest classifier model, and then let's check its accuracy, how well it's performing, and after that we will try different models from sklearn dot ensemble import random random forest classifier, and let's make object of this. Okay man, random forest classifier. Let's make object of that. Rd is equal to random classifier objects, and after that let's fit data into it. Rd dot fit xtrain comma ytrain. I think the data has been fit into our model. Now let's predict our values. Ypred is equal to rd dot predict xtest. Now let's see our data. What is the predicted value? Here is our predicted value. Let's check how much well it's performing, because the data is very less. So let's check how well is random parse classifier performing on this data. From sklearn dot matrices import accuracy score. Now just let's do one thing. Score is equal to ypred comma ytest original value. Let's now check the score. No man, we have didn't apply. Now check. I think 83% we are getting 83% accuracy score from use by using random forest classifier on this model. And let's check whether we can achieve a good accuracy from other models also or not. Let's do one thing. Let's import. I think it is kind of classification model, so we can only use a classification. The classification model will perform better. Okay, so we can try different classification model. We can try name based classification also, and we can also try logistic regression on that, and that's uh, that's it. And